So, good evening, dear all. Let us come to the topic of electric field due to system of charges. We have already learned electric field due to 1 point charge. Now, we have continued the topic to system of charges. Now, what is system of charges? System of charges is a group of charges. So, let us consider a system of charges Q1, Q2, Q3, so on Qn as the source charges and a unit charge which is a positive charge and which is having a very small value 1 coulomb. So because it is 1 coulomb, we are not writing it as a charge at the point P. So let this charge, that is the test charge, be placed at a point P. So we want to calculate the electric field at the point P due to the surrounding charges which would produce their own electric fields, right? So let us consider the charge Q1 and the test charge is also positive. So as both the charges are positive, they will definitely repel, and as learnt yesterday, the electric field is the force on the charge at the point P. So let us draw the repulsion. Correct? Similarly, let us draw the repulsion between Q2 and P. Let us draw the repulsion between Q3 and P. Let us draw the repulsion between Q4 and P. At present, I have just joined them and I have told that I am drawing the repulsion. So let us draw the repulsion shown by the green arrow due to Q1 at the point P, due to Q2 at the point P, due to Q3 at the point P, due to Q4 at the point P. Okay, and let us represent their respective electric fields as even vector, E2 vector, E3 vector, E4 vector. Right? So we have 4 electric fields at the point P due to the charges Q1, Q2, Q3, Q4. Then how do I calculate the net electric field at the point P due to these 4 charges? I will use the principle of superposition. The principle of superposition, as we have learned, is add all the individual electric fields E1, E2, E3, E4 vectorially. Then we get the total net electric field at the point P due to the system of charges Q1, Q2, Q3, Q4. If we take n charges, then Qn, which gives us En also has to be added, right? Okay, so now we also mark the distance as R1P between Q1 and P, R2P between Q2 and P, R3P between Q3 and P, and R4P between Q4 and P. And we are interested in the resultant of all these charges, and let us write that resultant as E somewhere here. Fine. Okay, so we have to first find out E1 according to the definition of, or according to the formula of E. What is E? Electric field formula: K, charge multiplied by the charge divided by the distance square between the charge and the point. So for E1 we will write it as K Q1 upon R1P square R1P cap, where R1P is the distance between Q1 and P and R1P cap is the direction of the vector E1 from Q1 to the point P. Similarly, E2 is equal to K Q2 R2P cap R2P square down. E3 K Q3 R1 R3P square R3P cap. Similarly, E4 vector equals K Q4 R4P square R4P cap, where R2P, R3P, R4P are distances from Q2, Q3, Q4 till the point P, and R1P cap, R2P cap, R3P cap, R4P cap are the unit vectors representing the electric fields E1, E2, E3 and E4 respectively. Correct? So according to the principle of superposition, to get the field, total field E, due to these four charges at the point P, we have to just add them vectorially. E2 plus E3 vector plus E4 vector. Similarly, if we have n charges, we will have En vector to be added in the last. So substituting these values, we have E is equal to, E vector is equal to K Q1 R1P square R1P cap plus K Q2 R2P square R2P cap plus K Q3 R3P square R3P cap and so on. Qn, I have not shown Qn, but it is understood that if we have n number of charges, then we get Qn, that is Rnp square, Rnp cap. Okay, so we get this as a vector addition. We can write it as a summation also, as E is equal to, K is common, rest of them we will put it in sigma. I is equal to 1 to n. It means that if I substitute I is equal to 1, I'll get the first term. If I substitute I is equal to 2, I'll get the second term. If I substitute I is equal to 3, I'll get the third term. If I substitute I is equal to n, I will get the nth term. Fine. So that's why it is written as sigma. Sigma, as I said, is summation. I is equal to 1 to n Qi upon RIP. It is RIP, okay? You know what, for what you write RIP. RIP cap. Fine. So this is the electric field of the system of charges Q1, Q2, Q3, Qn at the point P. Okay, so whatever is written, drawn, please understand, write it, draw it, learn it. This subject is not to be learnt in the last moment at all. Daily 5 minutes, 10 minutes, learn it, write it, understand it logically and remember it. Fine? Okay. So just take the screenshot as I move. So we have derived the equation for the electric field of a single charge and also the electric field for multiple charges. So whenever there is a problem related, numerical related to the electric field, some points we have to remember, which we will discuss right now one by one. The moment the question is find the electric field, all these points should come into your mind as a package. That is what is how to relate theory to numerical. So I have given the heading rules to remember while solving a numerical, whether it is for a single charge or whether it is for a multiple charge. So first thing I would write is the formula E is equal to KQ upon R square, where Q is the source charge and R is the distance between the charge and the point. Another formula we have E is equal to F upon Q. This is about the magnitude I am talking. E is equal to F upon Q, where force is the force between the source charge and the test charge, and Q is the unit charge which we have taken as a test charge. Okay, suppose if there is multiple charges, then E is equal to E1 plus E2 plus so on En. Right? So we have to add all the individual electric fields due to different source charges and add them vectorially. So whether single charge or whether multiple charge, these are the formulas which you have to remember. Okay, the next thing is how to, whether you are asked for a single charge or whether you have asked for a multiple charge, the first thing you have to do, where is the point and where is the charge. Okay, so if the charge is positive, go radially outwards. If the charge is negative, go radially inwards, but from the point, remember that. Okay, then another thing to remember is E is directly proportional to Q. That is already seen. That means how much bigger the electric charge, that much bigger is the electric field. E is also inversely proportional to R square, or is also inversely proportional to R. That also we have to remember this. Now when E0 is asked, sometimes E0 is asked. What is the meaning of E0? That means the point P is near Q. So let us substitute KQ upon 0 square. This is not defined. Remember, these are all PYQs. Let me write here PYQ. So it means if I consider the point very close to the charge Q, then the value of the electric field is not defined. Suppose I put E is equal to infinity. What is the meaning of infinity? I have placed this point P very far from the charge. Then what is my answer? KQ upon infinity square. 1 upon infinity square is 0. So my answer is 0. That means if I consider a charge and consider the point P somewhere very far from the charge, then the answer of the electric field which I get is 0. So very close, not defined. Very far, answer is 0 for the electric field. This is what the point to be remembered. Fine. Okay. So these are some PYQs which you can answer. Okay. So if the medium is not air, then E will be inversely proportional to epsilon R also. What is epsilon R? The permittivity or the relative permittivity of the medium. Okay. So if we are considering that the charge is placed in any other medium other than air, then E is inversely proportional to the relative permittivity of the medium also, where this epsilon R, as already taught earlier, is substituted in K, where K will become K is equal to 1 upon 4 pi epsilon naught epsilon R if air is not the medium. Fine. Okay, so these are the basic points to be remembered whenever there is a question about electric field. One more thing we can go ahead as a remembrance is the graph. So let us consider the graph between E and 1 upon R square. As you can read in the formula, E is directly proportional to 1 upon R square. So we must get a straight line graph from the origin. Okay, so how to read it as E is directly proportional to 1 upon R square, directly. If I read the same thing as E is inversely proportional to R square, then how do I draw a graph? I will get a negative graph, okay, where here x-axis is R square. Fine. So how to read this as E is inversely proportional to R square. Fine. So these are the possible graphs which we will see even in the later derivations which we will be doing. Fine. So these are the basic points to be remembered whenever the question is upon the electric field. Now keeping in mind the basic points, let us talk about how to calculate the electric field for a system of two charges. Okay, now this type of question was asked for this year, academic year 2025 CBSE board exam. Fine. So I have just drawn 4 triangles, you can see, but here I am considering the charge positive Q and positive Q placed at the two vertex of a equilateral triangle or a triangle, where the question is I have to find out the electric field at the point C. This is basic. I am not going to do any numerical, just basic how to find out the direction of the electric field from the point to the charge or from the charge to the point. That's all. Once we know to find out the direction of electric field, the other things will follow itself, adding vectorially by parallelogram law of adding vectors. Get done? Okay. So now, because both the charges are positive, how will I draw the direction of the electric field due to the positive charge from here to the point C? So only I am interested in, as I already showed you, we are interested only in the charge and the point. So what should I do? I go straight here. I go to the point and then, fine. So this is the electric field due to the charge plus Q at the point C. Similarly, let me go to another plus Q following the same rule from plus Q to C. Go outwards. Fine. Done. Okay. So now what should I do? I can name it. What can I name? I can write it as E plus Q and E plus Q. Fine. These are the electric fields due to the charge plus Q and plus Q at the point C. I am ready. So what is the resultant of these two? Upwards. This is the resultant E. Fine. Okay. So now let me consider another two polarities. Negative charge. This was a numerical this year. Negative charge. At A, I have placed a negative charge. At B also, I have placed a negative charge. So what is my rule? At the point C, what should I do? From the point C, I have to come inwards. Yes. This is the electric field. E minus Q along CA for this charge. This is the electric field again. E negative Q, I am just naming this. You can name it as E1 and E2 also. For the point C and negative Q. So what is the resultant of these two? The resultant of these two is vertically downwards. So how will I write here? Either I write vertically downwards. So this year in the board exam, they put one point M. So where is the resultant? The resultant is along CM. Agree? Similarly, I can name it as CX here. I can write resultant CX upwards from C. Okay, you can answer like this. Fine. Here because the M was given as a midpoint, so we wrote it as along CM Or what should I write? If this midpoint is not given, what should I write? From C, electric field, from C, downwards. Fine. Now let us go to another polarity. Let me take this as positive Q. Let me take this here as negative Q. At A, I have placed one positive Q. At B, I have placed a negative Q. Fine. Okay, again, I follow the same rule. From here, A, because this is a positive charge, I walk till the point C, go outwards. From B, I have placed negative charge. So, from C, I go till C, inwards. What is the resultant of these two? E. What should my answer be? If at all they are asking me only the direction, what should my answer be? My answer should be that the electric field is towards the right from C. Okay? That should be my answer. Only if the direction is asked. We will go to the magnitude also. Now, let us talk about another polarity where I have placed a negative charge here and I have placed a positive charge here. Again, following the same rule, what should I do? If this is a negative charge, I go from A to C. From C, I come in because this is negative charge. Again, from here, I go from B to C. I go outwards because this is positive charge. Fine. What is the resultant of these two? Here I have the resultant. I name it according to whatever I have. This is E minus Q. This is E plus Q. Directions are there. So let me draw the directions. Here also I can finish with E minus Q. E minus Q is E negative Q. I'm just naming it. Okay, E positive Q. Here also I have already named it. Here I have named it. So I am ready with the direction of the electric field. So what is the direction of the electric field here? Direction of electric field is towards left of C. So let the polarity be anything, whether two positive charges, whether two negative charges, whether one positive, one negative, or this side one negative, or that side one positive. The directions of electric fields by the individual charges and their resultant is ready. Direction is ready. Now, how do I find out the magnitude? How do I do the vectorial addition? Just by using the parallelogram law. What is our parallelogram law? Resultant is equal to A square. B square plus B square plus 2AB cos theta. What is A and what is B? A is this electric field, B is that electric field. What is theta for each of them? This theta is 60 degree. Ready? Fine. This theta is also 60 degree. Ready? I can take it as equilateral triangle. I have taken it as equilateral triangle. In this case, because this is 60, 120 is this angle between the two electric fields. Again, this is also 120. So like this, a general concept of how to solve such numerical should be framed in your mind. Let them change the value of this Q. Let them make it plus 2Q minus 2Q plus 3Q minus 3Q. Let them do anything. Let the question be anything. This should be followed. That if two positive charges are there, what to do? Two negative charges are there, what to do? One positive, one negative, what to do? You are done with this kind of numericals. All the possible methods I have shown. I can even change this. Let me make it to 2Q. Let us keep it as 3Q. Fine. Direction will be this only. Why? because both are positive. What will change then? Magnitude. What is the magnitude formula? E is equal to KQ by R square. What is Q? 2Q. What is R square? The length. Done. Okay, so let the magnitude be different. Directions are going to remain the same. Once you know the direction, magnitude, just substitute. Find out. Put it in this formula. Find out the resultant. Resultant is ready. Directions are ready for the resultant. That is the electric field due to these two charges at one point C of an equilateral triangle. Am I clear? Okay. So just take a screenshot of what I have done. And remember, this is a general fast revision. Okay. Okay. So now, just like how we saw charges for two vertices of a equilateral triangle, how to calculate the electric field, like that, there is another possibility where the charges are placed at the vertices of a square or a rectangle. Both are same. Fine. Okay. So we will try the possible variations in that. Fine. First, let us take all the charges at for the vertices are positive. Simply positive. And the electric field at the center O is asked. Okay. There is no hurry. Just listen. Okay. Now what to do? Our rule. Go to our rule. We have learned the rule. So what is our rule? Point. Charge. Charge to the point. Walk, walk, walk. Go outwards. Charge to the point. Walk, walk, walk. Go outwards. Charge to the point. Walk, walk, walk. Go outwards. Charge to the point. Walk, walk, walk. Go outwards. Fine. Why did we go outwards? Because all the charges are positive. You are ready with the directions. Now, in this case, I have taken all are of equal magnitude, plus Q, plus Q, plus Q, plus Q. When such question is coming, what is the formula we have to follow? E is equal to KQ by R square. Correct? Substitute these charges. It is understood that these four diagonals are going to be, parts of diagonals are going to have equal length. So the answer will be 0 for this electric field. Why? Why? You see on this diagonal, magnitudes will be same for these two. For this diagonal, magnitude will be same for these two. Fine. So what will happen? Their magnitudes will be same, directions are opposite, so here the electric field is 0. The magnitudes are same, directions are opposite, so here the electric field is 0. So total electric field is 0 for such questions, multiple choice questions. Is it clear? Provided all are positive and all have the same magnitude. If the magnitudes are not same, then you have to do the individual E1, E2, E3, E4 calculations. Because they are opposite, you find out E4 minus E4 minus E2. Depending on which is big, the direction will be that side. Suppose E4 is greater than E2, then the direction of this resultant will be towards E4. Similarly, here if E1 is greater than E3, then the direction of this resultant of this diagonal will be towards E1. So the resultant is above. Clear? So for finding out the resultant on a single line, your eyes should first go on whether the vectors are in opposite direction. If they are in opposite direction, subtract them. If they are of equal dimension, if they are of the same magnitude, answer is 0. If they are of different magnitude, one is bigger than the other, subtract and find out the direction according to which one is bigger. Here E4 is bigger. In this case, I have taken E3, E1 is bigger. How did I find out this? By finding out E1 minus E3. Here E1 was bigger, so magnitude will remain whatever answer I get here. But direction will be along E1. Clear? You are done. Then the angle between these two is 90 degrees. Solve using the resultant. Formula, what is our resultant formula? R is equal to root of A square plus B square plus 2AB cos theta. Here theta is 90 degrees. So now automatically this portion will become 0. Fine. This is the case when all are positive charges. If they are equal, Q, 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 my answer E will be equal to 0. If they are not equal, then find out individually E1, E2, E3, E4. On this diagonal, do E3 minus E1. Direction of the resultant is along the bigger one. On this diagonal, do E4 minus E2. Direction of the resultant is along the bigger magnitude. You got two magnitudes, two directions. Using the resultant method, solve the resultant electric field at O. Correct? Direction is ready with us. Fine. So this is when all the charges are positive. Fine. Now let us consider all the charges negative. All the four charges are negative. Again we will use the same method. The question is find the electric field at O. Same method we will do. What we will do? This is the charge. This is the point. Go inwards towards the charge. This is the charge. This is the point. Go inwards. This is the charge. This is the point. Go inwards towards the charge. This also go inwards towards the charge. Why? Because this is negative. Now you see they are nearly the same. Correct? They are the same. You did the same thing. But from here you went inwards. From here you went inwards. From here you went inwards and from here you went inwards. In this case, from here you went outwards. That's why they are looking same. Clear? Okay. So now I can write this as E1, E2, E3, E4. The method of drawing these directions was different than this. But look is same. Follow the same method as this. Fine. You will get the direction as wherever you are getting the resultant of these two and these two. Say these two, in this case these two are big. You have found out the resultant on this line, E3 minus E1. E3 is bigger. So direction is the side. Let me say E2 minus E4. Let me write here E3 minus E1. Next one, for the next diagonal, what should I do? E2 minus E4. Fine. In this case, E3 was bigger, so the resultant is here for this diagonal. And for this diagonal, E2 was bigger. So resultant is here. So what is the resultant of these two now? This one and this direction? This direction. Again, use the resultant and find out. Okay? Fine? Okay. So now let me take negative Q at this diagonal, positive Q and positive Q at the other diagonal. Let us see the story. How to calculate the electric field at the point O. That is the question. Question is the same. Okay. So again, let us start from here. This is negative. This is the point. So what should I do? I should go towards the charge. Name it E1. Fine. Okay. Now let me go here. I can name it as A, B, C, D to make it convenient instead of remembering here and there. Okay. So from A I have gone to B now. Fine. Now B is a positive charge. At B I have a positive charge. So what should I do? Walk. Walk. Go outwards. Let me name it as E2. Let me go to C now. Okay. It is negative. So what should I do? From the point towards the charge. Name it as E3. Okay. Now let me go to D. Positive charge is there. So from D, walk till the point. Go that words. Fine. Okay. Clear? Charges are different. Let me name this as E4. Charges are different, but the look is same. See, from here on this diagonal, opposite. From here, this diagonal, opposite. If at all the same setup is going on, then E is equal to 0. Here also, with the same setup looking at the diagram, E is equal to 0. This we will follow just like this or this, provided the polarities are like this only and the magnitudes are different. Let me name it as 2. Then I have to follow another story, as I already mentioned. If the magnitudes are different, then only I have to do E1, E2, E3, E4. If the magnitudes are same, then E is equal to definitely 0. But if the magnitudes are different like this, then I have to follow this procedure of finding E1, E2, E3, E4, go to the diagonal, subtract, find out which one is the bigger one, that is the direction of the electric field. Fine? Okay? So here I just rub this and write here minus Q and negative Q as previously written, such that E is equal to 0. If not, then I have to follow the same procedure. Now let me take 1/4 square, where I will take the same polarity on the same side. Now let me see what different I am going to get or same I am going to get. Again I am asked to calculate the electric field at O. Correct? Okay. Follow the same procedure. Let me write here A, B, C, D, so that there is no confusion. Go to A. It is negative, so arrow towards it. Go to B. It is also negative, arrow towards the charge. Go to C. Go to C. What is it? Positive. So what is the rule? From positive to the point, go outwards. So here if I name this as E1, if I name this as E2, then this is my E3. So you can see here what has happened. E1 and E3 are in same direction. So what should I do? I should add them. Fine? Okay. Then I go to D, point D. Again I do the same thing. Positive to the point. Positive charge to the point. Go ahead. Name it as E4. Okay. Again there you can see E2 and E4. They are in the same direction. So I should add them. So let their values be same. I must add them. I must add here for this case I must add E1 plus E3. Let me write it as E dash. Okay. Then I also have to add E2 and E4. Let me write it as E double dash. So the resultant of these two is ready with me as a magnitude. Then what is my E? Find out the resultant of E dash and E double dash using again the same formula of the resultant where theta is 90 degrees. Okay. So here how will I get my resultant? R is equal to E1 dash square plus E double dash square. E dash, I can name it different also if you are confused with dash. You can name it as EA, EB, whatever is convenient to you. Angle is 90, so I am not writing that. That is my resultant. And what is the direction? Upwards from O. What is the direction here? It is answer is 0. If not, the direction would be right side, left side, upwards, downwards. So how to mention the direction? You show it also, mention it also. If it is upwards, write upwards, 45 degrees, downwards, 45 degrees, towards the right or towards the left. Fine? Okay? 45 degrees from diagonal I can write. From the diagonal OA. This also can be written. Clear? So these are the general ideas which you can remember while doing such type of questions. And if you remember these polarities, as I said, all are equal, same polarity, all are equal, same polarity, all are equal in magnitude, polarities are opposite, same. Then also answer is E is equal to 0, E is equal to 0, E is equal to 0, provided the magnitudes are same. If magnitudes are not same, you have to follow this procedure. Fine? Only in this case, where upper side both are negative, lower side both are positive, answer cannot be E is equal to 0. No. Fine? So this you keep in mind so that you can be fast if it is a multiple choice question. Okay? So now I will just keep the page as it is, take a screenshot and understand it while revision. This is for quick revision. After this, I have solved this kind of 2 numericals. Fine? So you see how to solve that also.